It's a great honour to be here, and I'm very pleased to be able to be in the first of a new wave of vegetable sermons, which have been going on since 1729. And this evening I'm talking about flowers, and it's a subject I've always been interested in. I spent half my scientific career working with plants as a botanist. So that's also very good, and I'm delighted to have this family event as well, my wife leading the chanting and my two sons, Merlin and Cosmo, singing to us all. Sermons begin with texts, and the text is Morphic Resonance, which I think you have in your program. And why take ye thought for raiment? Consider the lilies of the field, how they grow. They toil not, neither do they spin. And yet I say unto you that even Solomon in all his glory was not arrayed like one of these. This passage is embedded in a series of statements about Jesus, about living in the present, trusting in God so you can live in the present and not worry all the time about what's going to happen tomorrow. The whole passage ends with that famous phrase, sufficient unto the day is the evil thereof. So it's about living in the present, being present. And Jesus invites us to consider the lilies of the field as an aid to that process. There are various translations of this passage, but what most people seem to agree is that he's referring particularly to wild flowers, not just to lilies. We do have lilies of the field this evening, lilies of the valley, which grow wild in England. And you also have some other wild flowers which were growing on Hampstead Heath until this afternoon. The lilies of the valley, there are some on the heath, but I didn't pick those because there aren't very many. There are thousands and thousands of these other flowers. And so what I want to do is think about flowers. So the bit I'm really going to talk about is consider the lilies of the field, how they grow. Well, the word consider, when I was thinking about this, caught my attention because I'm interested in the meaning of words. And sider is, as in the word sidereal, is to do with stars. So I suddenly thought, well, what does consider really mean? Its original meaning is to do with augury or divination with the stars. And it really means ponder deeply what you see, look for signs of it, look for a meaning in what you're looking at. And so that really is what I want to do this evening. The point about wildflowers is that they're natural, they grow by themselves spontaneously. They don't need breeders like Thomas Fairchild, the first of the great British flower breeders, in whom this, after whom the sermon is named. They just grow by themselves, and they've been growing by themselves for millions of years. The flowers, as soon as you begin to consider them, then you realize that flowers are different. Each species has its own kind of flower. And when in the 18th century, Linnaeus considered them, he realized that they form a way of grouping plants into families. Plants are classified according to what's called the sexual system of classification, because it's based on flowers, which are their sex organs, male and female, sex organs in the flowers. And as some of you know and some may not know, But each family of plants is classified according to the flowers it has, not according to the way it grows or the shapes of the leaves. So in the Leguminaceae, the pea and bean family, for example, there are peas and there are beans and there are sweet peas. And so there are climbers like peas and sweet peas and runner beans. There are shrubby little herb plants like chickpeas. There are shrubs like pigeon peas. And there are trees like acacia trees. But they're all in the same family because they have the same kind of flowers and pods. And one of the things I personally enjoy enormously is seeing family resemblances in plants. If you ever go to Kew Gardens, there's a marvellous part called the systematic beds. They're not the things that immediately catch your eye in botanic gardens, but most botanic gardens have them, Oxford, Cambridge, Kew, and others. And what they are beds of plants all in the same family. So you can go to a bed of plants that are all in the bean family, a bed of plants that are all in the peony family, a bed of plants that are all in other families. And it's very fascinating to see how the basic theme, the basic shape of the flowers, the basic characteristics, undergo all these different variations. You can see the family resemblances. When you consider flowers a little bit more, and you look at the structure of them, they fall into a number of basic categories. There's a whole group of plants, the monocotyledons, that include grasses, bamboos, palm trees, lilies, hyacinths, bluebells, and irises, where the flowers are in threes. The basic pattern is threefold, and sometimes they have six, where you've got 2 threes. The lily of the valley has 6 petals. It's basically 3 plus 3. You see the basic pattern here in an iris. This is the yellow flag from Hampstead Heath, where you see very clearly the 3 petals, and then there's 3 more inside, but they're in threes. So that's the pattern of this whole group of plants. Then there's a whole lot of other plants where the petals are all 4s, or 8s, multiples of 4. It includes the cabbage family, the Brassicaceae, and those include wallflowers, garlic mustard, which is growing on Hampstead Heath, but it's just finished flowering, so I didn't bring any this evening. But they have 4 petals. All the members of that family, wallflowers, cabbages, oilseed rape, mustard, and so on, have these 4 petals. And then many other families have 5 petals. And the ones you've got, all of you have examples of, they're all in different families, but they all have 5 petals. And there's many families where there are 5 petals. One of the plants you've got is red campion. Those are the red ones, Melandrium rubrum. Red campion is in the Caryophyllaceae, which is the pink family, which includes pinks, carnations, and sweet williams. And Thomas Fairchild's first cross, the first deliberate hybridization, which happened as far as we know in Britain, was between a pink and a sweet william with the Caryophyllaceae. And this is a wild example of the Caryophyllaceae. It has 5 petals, but each petal has a deep groove in the middle of it. So it looks as if it's more than 5, but if you look carefully, you'll see there are 5. Another 5-petaled flower that you have there is the blue one, which is alkanet. It's in the borage family, Boraginaceae. And that family includes comfrey, borage, forget-me-not, and this plant, alkanet, Pentaglottis sempervirens. And you'll see there quite clearly the 5 petals, of course, a different arrangement from the pink. And then the white flowers you've got are cow parsley, which is enormously abundant at this time of year, Anthriscus sylvestris, which is in the umbelliferae, the carrot family. And the umbelliferae have these compound flowers. They're like metaflowers. There's lots of little 5-petaled flowers within them, but they're arranged in these fractal structures. There's a kind of umbrella-like radiation of stalks, and at the end of each of those, the same thing happens again on a smaller scale to give you the little stalks, one for each of the little flowers. And if you look at those flowers, you'll see that on the edge of the head, each head of flowers, the petals, the outermost petals, are enlarged. So they exaggerate the sense of the flower. The ones in the middle, all the 5 petals are more or less the same. The ones on the outside are bigger, sort of magnifying the effect of the whole flower. So the whole flower, this cluster of little flowers, together looks like one big flower, and from a distance you get the impression of a big white flower. When you zoom in, then you see these smaller ones. And that process of metaflowers is taken even further in the Compositae, the sunflower family. I have here an oxeye daisy from Hampstead Heath. And the yellow bit in the centre of the daisy is full of tiny little flowers. Each is a little yellow flower. But the outermost ones have exaggerated petals. So you get this ray of petals, these rays of petals all around the centre. So many little flowers combine together to look like one big flower. And here the number of petals around the outside can be any number, because it's really a compound made of lots and lots of smaller flowers within it. And these, of course, have the splendid effect of being like the sun, with the rays coming out of it, which is, of course, why they're called daisies. Day's eye. The eye of the day is the sun. In Malay, the word for the sun, matahari, means the eye of the day. And so these remind us of the sun and its radiance. Now, when you think about these basic patterns of flowers, they're basic mandalas or patterns. And I think in the Middle Ages, they really took people's imagination in a big way. If you go to medieval cathedrals or abbeys, like Westminster Abbey or Lincoln Cathedral, there are many windows there, or in the decorated period of architecture, around 1300. There are many windows which have 4-fold symmetry, or 5-fold symmetry, or 3-fold symmetry, or 6 or 9 multiples. They're basically flower forms which are portrayed in the tracery of these windows. Now, to think about how do they grow, what our text says is consider the lilies of the field, how they grow. Now, how do they grow? Well, there's a certain basic things apply to all plants. They all need sunlight to power them with energy. They need minerals from the soil, nitrogen, magnesium, etc. They need carbon dioxide from the air. Those are the same for virtually all plants, except for parasites. And all the plants you have in your hand require the same light, the same carbon dioxide, the same kinds of things from the soil, and of course water. And if a different plant had been growing in the same place, it would have absorbed the same sunlight and turned into a different flower. It's the basic energy flow is essential for their growth, just like for us, the energy flow provided by food is essential for our well-being. But the very same crisp or peanut that you may eat afterwards, if eaten by somebody else, would become part of their energy flow, not yours. What makes us different is not the energy, because we could all eat the same food, just as plants all get the same sunlight, but something to do with form, the specific form. So how is it that plants take up their form? And how, in particular, how do flowers take up their form? Well, this is a big mystery. The answer is that nobody knows, despite intensive research, despite lots of laboratories working on plant growth. Most of the answers they've come up with don't really explain why the forms are different. Most of the answers explain why plants are the same. They all have photosynthesis and so on, but not the form that makes them different. And there are basically 4 theories of plant form, or of any form. And so I'll briefly outline them, and then say which one I think is the most relevant and important. First, the Platonic theory. As those of you who studied Greek philosophy will know, Plato had the idea that this world is a reflection of a transcendent world of forms or ideas. Beyond this world, outside space and time, there are the archetypes of all things in the world. So there's an archetype for red campion, there's an archetype for cow parsley, there's an archetype for alkanet in the realm of Platonic ideas. These forms are beyond space and time, and within space and time, they're reflected in actual organisms and patterns of activity. So that theory of form says that those forms are in the plant, but they're imperfect reflections of something beyond space and time. And St. Augustine incorporated this Platonic philosophy into Christian theology with the idea that the forms or are ideas in the mind of God. God had the ideas for all these flowers. They were what he called the rationes seminalis, the seminal reasons of things, and that they're then realized in nature. So God created by creating these forms in his mind through a kind of divine imagination, then they're reflected in reality. That theory, of course, leaves out the details as to how it gets from God's mind to the actual plant or hand. And this is something that was addressed by Plato's student Aristotle, the first and greatest philosopher who was also a biologist. Aristotle thought that these forms of each species, the forms of the leaves and the flowers, the form of the flower of the red campion or the alkanet or the cow parsley, that these forms were in the invisible immaterial soul that governed the plant. Each plant has its own soul, and the soul of the plant contains the form of the plant. The soul is the form of the body, as Aristotle said. The plant is inside its soul. The soul isn't in the plant's in the soul. That's true of all souls, according to Aristotle. So there's a red campion soul that shapes the developing red campion. And how it does that is by attraction. Souls work through attraction. They motivate things by pulling them towards an end or a goal. As the bud develops into the flower, it's pulled by the soul, attracted towards the unfolding of that flower until it's reached its final form, which you have in your hand. Then what takes over next is the development of the seeds, the fruits and the seeds, and those are pulled by the developmental soul of the fruits and the seeds. In the Middle Ages, Aristotle's philosophy was blended with Christian theology by St. Thomas Aquinas, and this was the theory taught in all our medieval universities, Oxford, Cambridge, Paris, Bologna, all over Europe, and in the monasteries. This idea that nature was made up of living beings with their own souls was the standard doctrine. According to St. Thomas and to Aristotle, animals also have a vegetative type soul that shapes the body, the embryo and the growth of the body. Animals have in addition a soul that organizes sensation, movement and instinct, the animal soul. Animals are called animals because they have souls. Anima is the Latin for soul. And humans, according to St. Thomas Aquinas, have a vegetative soul that shapes our body like the soul shapes a plant body. We have an animal soul that gives us our animal nature, our instincts, our emotions, the same emotions as animals have, like fear and anger and so on. And the same kinds of senses that animals have, eyes and ears. But in addition to the animal soul, we have a rational or intellectual soul, which is to do with conscious thought, the conscious mind. So the rational soul, the conscious mind to do with language, thinking and so on, is only part of our psyche. Most of it's unconscious, and we share it with animals and plants. This was the standard view in the Middle Ages, and it's that rational soul of ours which is open to the Spirit of God, according to St. Thomas Aquinas. So plants are shaped by their souls. Now the third theory of plant form came into being for the first time in the 17th century with the scientific revolution. The scientific revolution of the 17th century was a revolution precisely because it denied the existence of souls. It said animals and plants are not beings with souls, nor is the Earth. Everyone thought before that Mother Earth was a living being. They thought the stars and the planets were alive with their own intelligence or mind. Not so. From the 17th century onwards, the scientific revolution said, no, they're just machines. They're unconscious machines made of unconscious matter. And so plants are just unconscious machinery. There's no mind, there's no soul, there's no purpose. They come into being through mechanical forces working blindly according to mathematical or physical laws. Well, in the 20th century, that theory of plant development has undergone a great development within mainstream science. And many people thought that because of the discovery of genes and the genetic code and the advances of molecular biology, we'd be able to explain the form of plants by molecular interactions. Genes code for proteins, that proteins, these molecules that they make, would somehow interact with each other to give living cells. The cells would interact through chemicals diffusing around the plant to give particular patterns, and somehow this would explain the form. The problem is it hasn't, and it won't, because what genes do is code for proteins, for molecules. They don't code for forms. They code for enzymes, and so they affect something about the plant. The fact that that alkanet plant is blue is because it has blue pigments, and it has blue pigments because it has enzymes that make blue pigments, and that's because it has genes that give those enzymes. And if there's a mutation, a change in one of the genes, you could have a different colour. You could have white ones or other coloured flowers. The same with campion. It has red pigment made by enzymes that give you red pigments, and mutations can change the colour of the plant. But these enzymes don't actually explain the form. The form, how it comes into being from a mechanistic point of view, is a mystery. Still, despite all this research, because all you end up with is lots of chemicals, and the idea is they're meant to interact by bumping into each other at random, and somehow form just doesn't come out of that. I personally think that contemporary biologists hit a dead end and can't really go beyond this. It tells us something very important about genes and enzymes and proteins, but it leaves out the problem of form itself. Now, the fourth theory of form was one that was first put forward in biology in the 1920s, the idea that forms of animals and plants are shaped by morphogenetic fields. Morphogenesis means coming into being of form. Morphe is form, genesis is coming into being. That these fields are invisible structures that shape how the plant grows. We're used to magnetic fields, which are invisible structures in space within and around magnets. We're used to the Earth's gravitational field. It's in the Earth, and it stretches far out into space, holding the moon in its orbit and holding us down now. Without it, we'd be floating around inside this church. It's invisible, but it has a shape and a form, and that's what leads to the planets and stars being round. We're used to electromagnetic fields. Mobile telephones have them. Within the phone, there's a field, electromagnetic field, and that stretches out invisibly beyond your telephone, currently turned off. The field connects it with the transmitters and receivers invisibly. The idea is that within the red campion, as the flower forms, there's a flower field, which is a shape or a form, like an invisible mold or pattern, a resonant field that shapes the developing flower. The idea of morphogenetic fields is in fact rather like Aristotle's idea of the vegetative soul. And in fact, when you think about it, what's happened in science is that when souls were banned in the 17th century from science, they were exiled in favour of mechanical forces. What's happened is that they've been reintroduced, first by Faraday here in London with the idea of electric and magnetic fields in the 1840s. He put forward the idea that there are invisible structures around magnets and around charged electric bodies, which are called fields. And before that, in the 17th century, and indeed before the 17th century, ancient Greeks thought that magnets had souls. They thought the magnet had a soul inside it. Now the magnetic field, that soul becomes a magnetic field. People thought that the whole universe had a soul, the anima mundi, the soul of the universe that kept the planets and the stars in their places. We now have, instead of the soul of the universe, we have the universal gravitational field, thanks to Einstein. And so I think we have, in a similar way, these organizing fields in plants and animals giving the form. Now, what are they and how do they work and how are they inherited? This is more mysterious. My own theory, a controversial theory, is that they're inherited by a process I call morphic resonance. The past influences the present, depending on the resonant pattern of activity, on the basis of similarity. Each species tunes into a kind of collective memory of its kind. And so the red campion flowers are tuning into the actual flower forms of countless, millions, trillions of past red campion flowers. And the field is a kind of habit built up by resonance with all past red campions. They're the way they are now because that's the way they were before. Well, the same is true of alkanet and cowpasture. They've all got their own organizing fields which have a kind of memory, a resonant pattern. I think there are resonant patterns that work within the developing buds. We have a good analogy which can be shown through vibrating water. There's a device called the cymoscope, C-Y-M-A, scope, cymoscope, which vibrates small amounts of water. And with laser light and proper optical system, you can see amazing patterns appear on the surface of a little bowl of water when it's vibrated. And some of these patterns are fourfold, some of them are fivefold, some are threefold, some are sixfold or eightfold. They're very like flowers. And I think if there are vibrating patterns in the flower bud, that would help to set up these patterns that we see in the flowers. So this is still an open question. So amazingly, when you look at flowers, the flowers you've got now, or when you look at flowers in gardens or in your house or your own garden, the form those flowers take is simply, how they take it is simply not known. So consider the lilies of the field, how they grow. Well, people have been considering how they grow for a very, very long time, and we still don't really know. And this is, I think, one of the most exciting areas of biology, because I think as the mechanistic theory, with its rather dogmatic insistence on molecular mechanisms, proves increasingly inadequate, I think we're on the brink of a new revolution within biology, which will move us to a much more holistic understanding of nature. I want to finish by talking about qualities. What is it that enables us to appreciate the colours and the shapes and the smells? I think each row, you're having to share the lilies in the valley, they're in short supply, but do please pass it along if you've got one and smell it first, because I want us to think about smells as well as colours and shapes. Why is it that flowers have these qualities? What is it about them that makes them so attractive to us, both in smell and shape and colour? Well, the answer must be to do with animals. Charles Darwin, in one of his rare poetic passages, says that before there was an eye to see it, there could have been no flower. Flowers are a communication between the plant and the animal kingdoms. Without an eye seeing it, a flower makes no sense. Flowers do what they do. They attract mainly insects, bees, butterflies, beetles, in the case of cowpasture, and sometimes birds. They're attracting animals. And these qualities, the colour, the shape, and the smell, are attractors for these animals. This has nothing to do with human beings, or at least Historically, it didn't. Flowers first evolved about 100 million years ago in the age of the dinosaurs. After the age of the dinosaurs ended, about 70 million years ago, flowering plants became very dominant on the Earth. Before that, there were no flowering plants, before 100 million years ago. There were conifers, there were giant ferns. The coal measures that we give rise to coal are the remains of vast forests, primeval forests, but there were no flowers in those forests. Flowers are a relatively new invention in terms of evolution, and they must have evolved because insects enjoyed looking at them. The beauty of the flowers, the appeal of the flower, is dependent on the insect's eye. And that means insects must have an ability to appreciate qualities, colours and smells and shapes. They must have a sense of beauty. How otherwise can you explain the evolution of flowers? And we know that many animals have a sense of beauty. Other animals, in fact, think of the peacock's tail, an extraordinarily beautiful thing. It evolved long before humans arrived on the Earth. Is there, because female peacocks find it beautiful. Male peacocks compete to get the girl by having the most attractive tail. It's a big disadvantage to them in every other way. If they're chased by a dog, for example, they're lumbering to take off with this heavy tail. I've watched dogs actually snap at them and end up with a mouthful of tail feathers. So it's a big disadvantage in other ways, but it works. Darwin, with his very utilitarian way of thinking, called this sexual selection. It is indeed a form of sexual selection, and he said that explains it. But it doesn't really explain the beauty. It doesn't explain why female peacocks find it beautiful. It explains why the one with the biggest and best tail gets the girl, but it doesn't explain why there's a sense of beauty in the animal kingdom to start with. Now, according to standard neo-Darwinian evolutionary theory, everything that evolves for a use. And plants, insects that could see flowers and identify them would get more pollen or more nectar. It's useful. But that still doesn't explain why it needs to go so far in terms of beauty. You could think of a much more utilitarian system than the vast proliferation of forms that we see in the flowers. And moreover, according to standard biology, insects are mere machines. They're not conscious. Their nervous system just works like a computer automatically. In fact, our own nervous systems work like computers automatically. And the fact we're conscious is completely irrelevant from the point of view of mechanistic, materialistic biology, because consciousness doesn't actually do anything, even in us. It's just a kind of shadow of the activity of the nervous system. And insects are usually considered not to be conscious at all. It was only 3 years ago that leading animal behaviorists in the Cambridge Declaration on Animal Consciousness said that they'd come to the conclusion after the studying of a great deal of animal behavioral literature that higher animals such as dogs and cats had some form of consciousness and could actually experience emotions. Well, anyone who's ever kept a dog or cat has known that all along. But this is as far as we've got in the official statements, and certainly there's been no Cambridge Declaration on insect consciousness. So what is this sense of beauty and where does it come from? Well, it slightly depends where you start from. If you're an atheist or a materialist, then basically you'll admit that humans seem to be conscious and so on. But the basic assumption behind materialism and atheism is that the universe is unconscious. We live in an unconscious universe. It's wonderful, it's splendid, it's vast, it has stars and galaxies, it has been going on 14 billion years, but the whole thing's basically unconscious. There's no purpose in it, there's no mind involved. It's just blind following of laws and chance collisions of atoms. But if you believe in any kind of religion or spirituality, then you have a different starting point. There's a consciousness underlying the whole universe and inherent in it, throughout the whole universe. And if we take that view, which I certainly do, then that consciousness must be involved in the consciousness of the many things within the universe. An insect's mind is a mind and has a subjectivity, a consciousness, because it's ultimately derived from the source of all consciousness, the divine source from which all minds are derived. Our minds are derived ultimately from the divine mind and share in some of its qualities and nature. The whole of nature is a reflection of this creative mind that underlies all things. That's the traditional Christian view, and it's the traditional Muslim view and the traditional Hindu view as well, that there's a consciousness underlying all things. So the conscious source of qualities in the mind of an insect, the colours, the beauty, the ability of birds to perceive beauty in each other's plumage, or butterflies to appreciate the beauty of wings of other members of their species, is because these minds are derived from a divine source, a conscious source, not an unconscious source, but a conscious source. So then this raises the question as to the qualities. Does each insect have to evolve its own colour sense, its own sense of green and blue, its own sense of the quality of smells? Or are they just put together as mechanisms, say, by blind chance and mutations, and in the mechanism of the nervous system, and in the chemicals that are involved in transmitting nerve impulses? Or are these qualities somehow derived from a source, a conscious source of all qualities within which all minds participate? I personally think it's more plausible to think that the qualities, all the colours we can experience, green, blue, and so on, are there in the mind of God, and we participate in these divine qualities. And I've been thinking along these lines when I was reading a theologian that not much read today, St. Anselm. St. Anselm was Archbishop of Canterbury in around 1100. And in one of his meditations on the divine nature, he's talking about God's mind. What's God's mind like? What's it like to be God? Obviously, we can't imagine with any adequacy what it's like to be God. But one of the things St. Anselm talks about is that the God is that which nothing greater can be imagined. God, in other words, contains all conceivable possibilities. God's mind contains all possibilities that can be expressed in the universe or experienced by any mind. They're all there in the divine mind. And so then he has a fascinating discussion where he discusses whether God can smell roses. And he said a God that could not smell roses would be less perfect or less complete than a God that could smell roses. And on the principle that God is that which nothing greater can be imagined, the God which can smell roses is greater than a God that can't smell roses. Therefore, God can smell roses. And God can smell lilies of the valley, and God can appreciate the beauty of red campions, and of alkanet, and of cow parsley. I think that's a marvellous way of thinking about it. And I think when we see that all minds, including insect minds, which are the underlying basis for this great beauty of the floral kingdom, participate in the divine nature. The divine nature is immanent in nature, within nature, as well as transcendent nature. God is within the natural world, in every part of it, in all places, but also beyond it. This kind of theology is called panentheism. Pan means everywhere, en means in. God is in nature, and nature is in God. Different from pantheism. Pantheism is God is in nature, and that's it. But panentheism, God is in nature, and nature is in God. The divine mind transcends nature, although it's fully present in all of nature. So I think that these are some of the thoughts that can come to us when we consider the lilies of the field. I think one of the reasons why Jesus' injunction is so helpful when we take the lilies of the field to mean wild flowers is that when we look at wild flowers, we can be completely present. When I look at flowers in my garden, I love the flowers in my garden, and that's why I put the plants there and weed the garden and water them and so on. But whenever I look at flowers in my garden, I can't have that sense of presence so much, because I always notice something I haven't done, or something a weed that needs taking. I can't relax in my garden in the same way I can when I'm walking in the countryside or on Hampstead Heath. When I see the wildflowers on Hampstead Heath, I don't feel any need to weed anything, because they are all weeds. I mean, weeds are just plants in the wrong place. And these wild plants on Hampstead Heath are in the right place. I don't feel any need to do anything. And so it's much easier to become present. That sense of divine presence is what we're invited to live in by this text of Jesus. If you are worrying about tomorrow, then you're thinking about some other time. You can't be present. If you're fearful, you can't be present, because you're worrying about the things you're afraid of. And I think many of the aspects of the Christian and other religions are about trusting God in such a way that you can reduce your level of fear. There's a wonderful prayer that occurs in Evensong in the Church of England, where God is asked to deliver us from the fear of our enemies. We're going to go on having enemies, but if we can be delivered from the fear of our enemies, we pass our time, as it goes on to say, in rest and quietness. And unless we're able to live without fear and without worry, we can't be present. And we can't really contemplate or consider the lilies of the field unless we're present. But conversely, contemplating the lilies of the field helps us to become present, because they are part of the divine presence that is expressed through nature to us. Thank you.